have opened the schematic here. See, PL4801. It is a 1.05 volt power. Yes, it is a 1.0 volt power. And which IC is responsible to generate this voltage? See, this is the regulator IC. Okay. This IC RT8237. This IC is responsible to generate the 1.05. And see here, pin number 1 power good. It is going to for 1.05 VTT underscore power good. It is taking out the supply for this. Okay. Now we have to check this area. Okay. In back side, see here in this side only the coil and capacitor, and this all MOSFET and IC is in the back of this. That means it is here. This IC number is PU4806. That means yes, this is the IC PU4806. Okay. Oh my God. See, while editing video, I got the region. See close. Yes. Yes. Here is some junk. Means here is some corrosion. Yes, it is quite showing me that there is a corrosion of this pin. I see pin number, maybe pin number 1. Yes, it is pin number 1. Not it is a corrosion in area. See, close. Yes, PR4823, PR4824, and PR4822. Yes, and one capacitor PC. Let us see this corrosion area belongs to which pins. Yeah, see, this is the PR4822. See, close. PR4822. This is this resistor PR4823. This resistor PC4823. This capacitor. Yes, these two resistor, one capacitor is get corroded. Means it is having corrosion. And what is this resistor and what is it is doing in this section? What the work is doing by this resistor in this section? That means this resistor is given out of the coil, means output of the coil, and it is coming down here, and it is giving us the 1 power underscore 1.05 underscore FB, and this FB line is connected to this power underscore 1.05 FB, pin number 4. That means this pin number 4 is not getting its proper feedback. Pin number 4 is not getting its proper feedback, so it is power underscore 1.05 FB, and this is the resistor, both resistor and one capacitor. And see, this pin number 4 is connected with this resistor pin is connected with this resistor. That means it is a feedback, and this IC is not getting proper feedback, and maybe the reason of this, it is getting low output. Okay, now let us see. First of all, we have to clean the corrosion. Again, I will show you the corrosion area. See, very closely you can watch. Yes, it is the region of 3D. So physically, whether you have to see the whole motherboard very carefully, you will get the faulty area. Okay, now I will clean this area. And friends, now see, I have cleaned the area of that where it was getting rusted. Okay, corrosion. I have just cleaned. Now I will check by giving DC supply. Okay. Giving DC supply and putting that CMOS back. Now I'm getting that DC check. Now see the DC supply. Now same case. It is giving me same case. Problem is not resolved. See, same case. Same case. Now I have to check the resistor value. If resistor is faulty or what, let us see. Okay. Now see the schematic. The resistor, first resistor, the value is 10K, and the second resistor value is 21 kilo ohms. Okay. The first resistor value is 10K, and the second resistor 21 kilo ohms. And there is one capacitor, but it is rubbed. It is not there. Place this capacitor, and another resistor also there is. That is PR4824 or not. Let us see which resistor. So there are 3 resistors is getting corroded. Yes. PR4822, 4823 and 4824. Now schematic 2223 and 24. Let us see which is the place. This is the 4823, 23, 22 and 24. 24 where it is? PR824, 24. It is PR421. Yes, this is 24. Okay. And this is the, see, it is the register. This is one pin in ground and another is joined with the 5 number pin. Okay, 4 number and 5 number is getting issued, and this is the 470 kilo ohms. One and another is 10 kilo ohms and another is 20 kilo ohms. Let us check. Okay, now we'll check in multimeter. I will keep. Now see, brother, here it was very much corrosion. Now I cleaned, see, I cleaned here. Okay, now I clean this area. I replace these two divider resistor here. Okay, though my problem was not solved, it was generating low output. Okay, after that, what I did, I replaced this IC. Here is one IC I replaced. See, I replaced this IC. Another IC I just replaced. I replaced this IC here in place of this. It was faulty and I replaced this IC. Now I'm going to check the laptop whether it is okay or not. Okay, now see my DC supply. Today I'm self-shooting this video for you guys. See, now I'm putting the DC jack here. Okay, one hand in my camera and another hand I'm putting DC jack. Now see, DC jack, I put DC jack, the ampere is good. Now it is not starting itself. I have put in my CMOS battery also as well as. Now I will go to trigger the laptop and you guys see the DC supply reading. Yes. Yeah, see, the reading is okay. It goes up to high to 340 pp and it down. That means now laptop is okay. See, fan is revolving. Okay, now I'll put my keyboard for checking this display. This is my keyboard and I'm putting this wire. See, I'm putting this keyboard wire here in this USB, and now see, this light has been blown. Okay, this off on, off on, off on. Now this is okay perfectly. Again I will shut down. See, like this. Now see the DC. I will shut down my laptop. Yes, now this is 0. Now I will trigger again. Just see, guys. Yes, now see 400. Yes, keyboard light is gone. That is now laptop is perfectly okay. Hope this video is useful to my head members as well as all the viewers. And this type of fault is very common in this Dell 3542 3-bit, and maximum laptop I have repaired by resolving this area. Sometime I get register fault and sometime I get ICs, sometime MOSFETs, but this whole area is responsible for maximum 3-bit error. Okay, thank you for watching my videos. Myself Jyoti Karmkar from laptop Sen Infotech Laptop Repair and Training Center, Purnia Bihar. Thank you. Keep watching.